Okay, so we practice finding a general solution. We're now going to actually find a particular solution to an initial value problem. And let's see if we can, I'll give you some step-by-steps here just to make sure that you can follow along. But so this is the differential equation, the system that you want to solve. And this is your initial value. Okay? Now I want to say something really quickly. So on your final exam, I will not, so listen to me. So I will not ask you to find determinants of anything larger than a 2 by 2 matrix. All right, so notice that this is a 3 by 3 matrix that you would have to find, that you would have to take the determinant of to find the eigenvalues. So what I was trying to say is, if I ask you to find eigenvalues in order to get to the solution, then it will definitely be a 2 by 2 matrix, because that's for just the scope of time that we have. I'm not going to ask you to do anything more. So what you would have in a situation like this is I would say find a particular solution for the following initial value problem, and then I would say given, and then I would give you your eigenvalues. In this case, 1, 2, and 3. So does that make sense? That you don't have to find eigenvalues. In other words, you don't have to take determinants of 3 by 3 matrices. By the way, it's not that bad. In fact, if you think back to your work with cross products, it's not that bad. It's just, I'm not, for the sake of time, I will give you the eigenvalues if it's anything more than a 2 by 2. If it's a 2 by 2, then you'll actually find the eigenvalues. So in this case, now that we have the eigenvalues, what are we going to do? Well, we're going to, so given the eigenvalues, we're now going to find the eigenvectors. So first would be to find the eigenvalues. Second would be to find the eigenvectors associated with each eigenvalue. And let's go ahead and start. So to find the eigenvector, let's start with the eigenvector of lambda equaling 1. So you remember how to do this. It's just simply going to be a minus lambda I, c is equal to 0. Now what I'm going to do is, again, I'm trying to just give you a few more looks at this before I go to the next topic. Just with a, we know the value of a, and we know the value of lambda. So this would be, this portion right here would be a 3 by 3 matrix with 1s down the diagonal. Okay. And I'm going to go ahead and subtract these. So I'm going to get us to that part. So that after we do our subtraction, we would have 0, 2, negative 1, 1, negative 1, 1, 4, negative 4, 4. C is equal to 0. Okay? Now, I'm going to go ahead and write that just like I did previously, with the fact that C, in this case, would be equal to C sub 1, C sub 2, C sub 3. So I need to know that eigenvector. Okay, so 0, 1, 4, 2, negative 1, negative 4, negative 1, 1, 4, C sub 1, C sub 2, C sub 3 equals 0. All right, so simple enough. What you're going to do in this case is you're going to take matrix A, have it set equal to 0, right? So, and then you're going to RREF. So in other words, what you would have is you would have matrix A and you would have it as an augmented matrix set equal to 0, and then you would begin your row reduction algorithm. So let me go ahead and tell you what that would equal. So you would end up with 1, 0, 0, 0, 1. My handwriting is not that great, so yeah, so 0, 1, 0, 0.5, negative 0.5, 0, and then 0, 0, 0. All right. So in this case, what you can, the way you can think about it as you have your, you're going to see some free variables here. So you can see right now that C sub 3 is a free variable. These are pivot positions. These are pivots, C sub 1 and C sub 2. These are your basic variables. And now what you're going to do is you're going to write C sub 1 and C sub 2 in for, or in terms of C sub 3. Ready? So C sub 1 would be equal to, just imagine this equation here. Listen, I know for many of you, you remember this from linear algebra, but I just want to make sure you understand that after I wanted to scoot this over a little bit, C sub 2, C sub 3. So let me turn this back into a system so that you would understand it. So this would be C sub 1 plus 0.5 C sub 3 is equal to 0. That's the way you would think about that, okay? Then you would have C sub 2 minus 0.5 C sub 3 is equal to 0. And then you would just simply have 0 equals 0 here. So if you solve for your basic variables, I would have C sub 1 is equal to now negative 0.5 C sub 3. Then you would solve for C sub 2, bringing this to the right. So C sub 2 would be equal to positive 0.5 C sub 3. This is going to be negative 0.5 C sub 3. C sub 2 is going to be equal to positive 0.5 C sub 3. And now your job is to choose a free variable, right? That's what you're doing here. So we're going to let C sub 3 equal 2, right? Because half of 2 is 1. So that should be fairly easy. So let's take a look at the form of our eigenvector. So C sub 1, C sub 2, C sub 3, right? So C sub 3 here is free. And now let's go ahead and letting C sub 3 equal 2, let's form our vector. So negative half of 2 would be negative 1. Half of 2 would be 1. And what did we say C sub 3 is? Well, we said it was 2. All right. So this is the eigenvector associated with the eigenvalue of 1. Now I'm going to go ahead and give you the other two eigenvectors. All right, so let me go ahead and write. So we had negative 1, 1, 2. This is when this is given an eigenvalue of 1. We would have, and you can verify this on your own, negative 2, 1, 4. This would be when you have an eigenvalue of 2. And then finally, negative 1, 1, 4. This would be the scenario when you have an eigenvalue equal to 3. Okay, so are you with me that what you've done, you were given 3 eigenvalues, and you were able to find the associated vectors, the eigenvectors. that are associated with each eigenvalue. So at this stage, let's get to our general solution. All right, so x of t is going to be equal to c sub 1 e to the, now lambda is 1 in this case, so e to the t times negative 1, 1, 2, plus c sub 2 e, now in this case lambda is 2, so e to the 2t, negative 2, 1, 4, and plus c sub 3 e to the, in this case lambda is equal to positive 3, so 3t, negative 1, 1, 4. Okay. So this is the general solution. Now, we can go a little bit farther with this problem because we were told, right, if you recall, because we were actually given a little bit more information. We were told, let's see if I can pull it, that x sub 0, or x of 0, is equal to negative 1, 0, 0. All right, that was, let me make sure that was, I'm not copying something incorrectly really quickly. So let me go back and make sure I'm pulling it. Yes, x sub 0 is equal to negative 1, 0, 0. So x sub 0 is equal to negative 1, 0, 0. Okay, that's what I thought. But, all right. So now how do we go from general solution to particular solution? Well, indeed, really what you're doing is you are plugging 0 in for t. All right, and then you're setting it equal to the following vector. The only thing is, I've seen a lot of students go astray here. I want to make sure you understand what it is that you're setting equal to 0. All right, so what you're going to end up with, if the easiest way is, and this is true in this case specifically, because what we have is when we have e to the power of 0, that's equal to 1. So we end up with, I'm gonna go ahead and use the fact that t is equal to 0, and when t is equal to 0, I know what the vector, what this matrix is going to be equal to. So ready? Let's go ahead and write it out. C sub 1, C sub 2, C sub 3. All right, ready? So it's no longer equal to 0 because we were given an initial value, right? So this is going to go here, negative 1, 0, 0. And now, what we're going, in this case, because it's x of 0, we're simply going to end up with negative 1, 1, 2, negative 2, 1, 4, negative 1, 1, 4. And now, let me show you how students go wrong here. Notice that our matrix A was just composed of the columns of our eigenvectors. Just make sure that you understand that that's a consequence of the fact that you have t equals being equal to 0. If you had something else, like if you said x of 1 equals, then this is, I'm going to go ahead and use a different color here, because what you should have done, what we didn't have to because this is so easy when it's x of 0. But here's what you really should have done. This would have been, if you multiplied this out, right, this would be negative e to the t, e to the t, 2e to the t, negative 2e to the 2t. Now listen, if you're wondering where these values are coming from, just hold off for just a second, okay? 4e to the 2t, negative e to the 3t. Then we'd have e to the 3t. Then 4e to the 3t. All right, are you with me? So hold on for just a second. So if we say e to the t times negative 1, we get negative e to the t. If we say e to the t times positive 1, we get e to the t. If we say e to the t times 2, we get 2e to the t. You're with me on how these columns were formed. Now, it just so happens that if you let t equal 0, in this case, we end up with negative 1, 1, 2, negative 2, 1, 4, negative 1, 1, 4. But if this were x of 1 equals some vector, then you would be plugging a 1 in for t here, here, here. I need you to understand that. You don't get to just jump right to whatever my eigenvectors are, they become my matrix. No, that is a special scenario where the t value is equal to 0. So I hope that that makes sense. Now, at this stage, the good news is the calculator can do all of this RREF. So again, now you take your matrix, but you're not setting it equal to 0, right? You're setting it equal to the initial value, negative 1, 0, 0. But again, the good news is now you can just RREF. And what do you end up with? You end up with C sub 1 being equal to 0, C sub 2 being equal to 1, and C sub 3 equal to negative 1. All right, so I hope that you were able to follow me through that. The only thing left is we just don't want to be sloppy with our work, right? I mean, you were asked to find the particular solution. You have everything that you need. It's all sitting here. But you need to go back and plug 0 in for C sub 1, and 1 in for C sub 2, and negative 1 in for C sub 3. Listen, these arrows that I'm drawing are not optional, because it's not my job to hunt through your work and try to figure out what the particular solution is, right? It's not the client's job to piece together what the product is from your scratch work. It's your job to present the product, right? And the only thing that you need to do is plug in for C sub 1, C sub 2, and C sub 3. And then you actually have the particular solution to that system of differential equations. All right, so I think it's a good time to take a break, and we'll see you in the next video.